To name a plane, you're always supposed to use 3 letters. The only points that are not on the plane are A, C, and F, so any other 3 letters like E, G, H, or whatever would work for number 1. Number 2, the line intersects the plane at point B. Number 3, H, G, and G intersect at point G. Notice G is in the name of both lines. Number 3, collinear means they share a line. You will need to know that. A, B, and C are all in the same line. Number 5, F or C or A are not on the plane. Number 6, no, because F is not on the plane. If they don't draw it on the plane, even though planes go forever, you can assume it won't hit the plane if you extend it out. Okay, just so no, those points are not coplanar. Actually, through any 3 points, you could draw a plane. So if you look at D, E, and F, you could draw a plane through those 3 points, no matter where F is. You kind of have to use your imagination, but if you throw B in there, then you have to kind of curve it, so it won't be a plane. So anyway, 6 is no. Long way to say 6 is no. Number 7, if they just put a letter, that means it's just a point. So you just put a dot P for number 7. Number 8, to draw a plane, you just draw a little parallelogram. And it doesn't really matter where you put those points on the plane. You could put them on the corners, or you can just put them, you know, X, Y, Z. 9 is a line, so TQ can be anywhere on the line. 10, if they put a little cursive, it's not really cursive, but a little, you know, fancy letter, that means a line also. So sometimes they do that instead. So on 11, cursive or fancy Z is intersecting TQ. So we'll call that TQ. Call that Z at M. So something like that. 12, A is not on plane S. So sometimes, just like you can call a line with just 1 letter, you can call a plane with 1 letter. So they call it S, so you just put it in the corner there. A is not on point S, something like that. Number 13, 3 non-collinear points. Really, all you have to do is draw 3 points, not in a line. That's the only thing you have to do, and I guess they're called G, T, and Y. Number 14, the sides of the pyramids are not planes, but they are part of a plane. Like, you could say plane JXB, that would be like the front of the pyramid, but there's a plane that's represented by that face. So there's 4 lateral surfaces to the pyramid. Those are all planes, plus there's the bottom plane of the pyramid, so that adds up to 5. 14 has 5.
So they are or they are not? They are.
Okay.
You said they're not.
Planes go forever. The sides of the pyramid are limited, but they are a part of a plane.
Okay.
So there is a plane JXB, but triangle JXB is not a plane. It's just part of the larger plane.
Okay.
You can't really draw a plane because it goes forever, but it's represented by that surface.
Okay.
So there's 5 planes anyway. Number 15, how many planes contain H? Well, if you look, the back of the pyramid, the left of the pyramid, the bottom of the pyramid, those are all touching H, so that's 3 planes. There's only 3 points that are collinear in that picture. Which ones are they? J, T, and N. They're the only 3 in a row. Any 2 points are in a line. Did I say plane? Any 2 points can be in a line. But 3 points not necessarily in a line. J, T, and N are collinear. Number 17, 2 points not on plane XBN. Which plane is plane XBN?
The bottom.
The bottom one. So anything not on the bottom, so anything besides H, which would just leave J and T, I guess. Number 18, 4 points that are coplanar. Kind of just mentioned it, HN, XB. Those are all on the bottom plane. 19, so I did, for that you don't put a symbol, you just put like H, comma, N, comma, X, comma, B. There's no symbol for a point. You just write it out with the commas, with the letters. 19, name a line that does not contain J. What did you guys put for that one? NB, okay, or NH or XB or anything on the bottom there will not have J in it. Name 3 non-collinear, so that number 19 should have had a line symbol. So when we're talking about a line, you should use a line symbol. When we're talking about a segment, you should use a segment symbol. When we're talking about a ray, you should use a ray symbol. Name 3 non-collinear points. Lots of options here. Well, the only 3 collinear points are J, T, and N. So as long as you didn't put J, T, and N, you got it right, basically. Any 3 points besides those would have been right. All right. Let's see if you guys can get this from memory. A 3-sided polygon is called a triangle. 4-sided quadrilateral, not a rectangle, not a square. Those are types of quadrilaterals. What's 5 sides? Pentagon, like that building in Washington, D.C. 6 sides? 7? Heptagon. 8? Octagon, that's the easy one because I don't know, it's popular, I guess. Octopus, I guess, maybe. 9? 9 sounds like, non sounds like 9, nonagon. 10? Okay. Those are the only ones you'll be. Past that, they really don't have. Remember, we learned dodecagon. Well, actually, we learned.
Isodecadron, but we didn't. And then they just started leading numbers and then gone at the end.
Okay, dodecagon though was not a polygon. Wait.
Yeah, it was.
We didn't learn it as a polygon, though, did we?
Yeah, we did.
We learned it as a 3-dimensional shape, a polyhedron.
We did dodecagon and dodecahedron.
We did 12
we learned
different
that.
polygons, but we did.
Anyway, it would be dodecagon, and we learned dodecahedron. I don't know if the word dodecagon is. Anyway, don't worry about anything past 10. I do want you to know dodecahedron and icosahedron, those 2 things we learned last chapter. Anyways, so number 1 had 7, so it was supposed to be a heptagon. 2, decagon, unless I counted wrong. I did this myself, so I might have made a mistake. Number 3, I got 9, so nonagon. 4, I got hexagon. 5, I got pentagon. 6, I got 9 again, nonagon. 7, I got hexagon. 8, I got 9 again, nonagon. Okay, convex, concave. Concave just means it's got a little cave, an indentation somewhere. Like one vertex is inside 2 other vertices. That's part of the definition. But if it doesn't have a cave, it's convex. So 9 and 10 are convex. 11 is concave. 12 is convex. 13 concave. 14 concave. What does regular mean? All sides and angles are the same. It is possible, like on number 22. No. Oh yeah. It is possible to have, never mind. Okay, so on 15, 17, and 20 are all regular. All the sides are the same, all the angles are the same. A concave hexagon, yours might look a little different than mine, but this is what I drew. So instead of going out right here, I just went in right there. That was mine. Just It just has to have 6, doesn't really matter what it looks like. I found 2 impossibles on 22. I think I might have thought there was 3 at first, but then I realized there's just 2. A concave trapezoid. Not possible. A trapezoid has to have 2 parallel sides. So any way you draw it, there's no way to get a cave in here because there's just not enough to work with. So concave trapezoid, not possible. Concave triangle, not enough sides, impossible. Can't. I mean, I don't know how to prove that. There's just, you can try to think any way to draw it. There's no way to draw a concave triangle. Do you guys think there's any other possibilities? Concave equilateral pentagon. I thought that might be impossible for a second, but equilateral means equal sides. So I think there is a way to draw it like this where all the sides are equal. There's probably more than one way, and that is definitely concave. Anyway, that's kind of a weird question, but that won't be on the test, to be honest. Alright. Adjacent angles are angles that share a side. So technically number 1 is adjacent, but we can be more specific than that. If they're adjacent and they make a line together, we call that a linear pair. So number 1 is a linear pair. What do we know about linear pairs?
They're supplementary.
Right. They're supplementary, or in other words, they have to add up to 180 degrees, because a straight angle is 180 degrees. What do you guys put for number 2? Adjacent. 3, adjacent. Okay, 4 is adjacent also, but we can be more specific because it makes a right angle. Those are complementary. Angles that make 90 degrees together, complementary. Number 5, angles across each other, opposite each other, are called vertical. When 2 lines intersect, the opposite angles are vertical angles. They're always congruent. That was one of the theorems we used a lot. You guys remember that? I will put a proof on the test. We'll talk about it today. I tried not to make it the easiest kind, but not a hard one either. Kind of in the middle. Number 6, what did you guys put for that one? Adjacent. 7. Yeah, a linear pair. 8. Vertical. Okay, speaking of linear pairs making 180 degrees, number 9 would be 180 minus 50, so 130. Number 10, vertical angles are all congruent, so B is 43. Number 11, what do those 3 angles have to add up to on number 11? 360. So you do 360 minus 209 minus 96. 55, 12. Those 2 have to add up to 90. 90 minus 63. 7. All right. Number 1, when you have isosceles triangles, that means you have 2 equal sides, but when you have 2 equal sides, you're going to have the opposite angles are going to be equal as well. We called the equal sides legs. We called the other side a base. The base angles are always going to be congruent. Basically, the angles across from the sides. We might actually miss some problems on this. We'll see if you guys figured it out or not. So number 1 was just 12. Number 2, x plus 22 equals 12. So you subtract 22 and get negative 10. Number 3, the top and right angle have to be 55 degrees, which leaves 70 degrees for the bottom left angle. So 70 degrees is the answer on 3. Number 4, similar trick. The 2 angles on the right are 76 degrees because they would be the base angles. And then the top little angle would be leave 28. Remember, the angles of triangle have to add up to 180, so 180 minus 76 minus 76. Number 5, 77 and x are both base angles, so x is just 77 on that one. Number 6, same thing. 70 and x are the base angles, 70 degrees. Number 7, all the sides are congruent, so all the angles are congruent, so 60 degrees. Number 8, if you do 180 minus 40, that leaves 140. The base angles are the same, so 140 divided divided by 2. For the bottom two, for the right two angles, leave set beneath for x. Okay, number 2, or 9, I mean, the two base angles are 40. 40 and 40 is 80, that leaves 100 for angle 2. So you're supposed to do 100 equals 112 plus x. Subtract 112, you get x is negative 12. Number 10 is kind of the same thing, but 2 is 60 degrees, just like number 7. Angle 2 is 60 degrees, so you do 60 equals negative 3 plus 7x. Add 3, divide by 7, you get x is 9. Okay, on number 1, when you have twin angles, see how both x and y are in the upper right corner on those groupings. If the lines are parallel, they should be the same. Those are called corresponding. The twin angles are corresponding angles. What do you guys put for number 2? Alternate exterior. They're on alternate sides of the transversal, that line going through, and they're exterior to the parallel lines. Alternate exterior. What do you guys put for 3? Corresponding, they're matching. Number 4, when we did this, I called them same side interior. This page calls them consecutive interior. You guys remember what we knew about consecutive interior or same side interior angles on parallel? Yeah, they should add up to 180, which we need to apply that when we get to the parallelograms. Same side angles should add up to 180. Brian, just pull a book out. Put it away. Did you just pull a book out? Huh? Number 5, what do you guys put for that one?
Alternate interior.
Yeah, interior because they're between the parallel lines. 6, alternate exterior again. 7 and 8 got a lot of lines going on, so they might have confused you. There's only 3 lines that matter though, the 3 lines that make up the angles. So on 7, if you simplify that picture, it would look like the outside parallel lines. So they're alternate because of alternate sides of the transversal. Interior because they're inside the 2 parallel lines. Same thing on number 8. If you simplify that picture to just the lines that are making the angles. There's y, there's x. So it's alternate exterior. Basically, all those angles, when the lines are parallel, are either going to be congruent or supplementary. They all were equal to each other, or they added up to 180 with each other. Okay, I'm not going to put like 8 questions of this kind on the test, but maybe doing it 8 times will help you remember. What's the formula for finding the sum of the angles in a polygon? Right. Okay, I am going to put that on the test. Did I tell you guys you could make a page of notes? You can make a page of notes, so if you want to put that formula like that on there, that's a good idea. You can write whatever you want on the page of notes. I'm fine with that. I'm also probably going to put on the test, like 99% sure, a question, I'll say 90, where they want you to just find one angle. We'll talk about this more in a little bit, but if you have a regular polygon with just one congruent angle, or one angle, so this finds all the angles. So if you just divide that by the number of angles, which is the same as number of sides, that would give you one angle in a regular. It only works in regular polygons because all the angles would have to be the same for this to make sense. This is sum of all angles in a polygon. Doesn't really matter if it's a regular polygon up here, but for this one it has to be regular. Alright, what'd you guys get for 1?
2,420 degrees.
3,420, what'd you get for 2?
900.
3,
1,008.
4,
720.
5,
1,800.
6,
1,260.
1260, 7, 360. You guys should have that 7 memorized. Any quadrilateral is 360. 8.
1,440.
Alright. This page I'm kind of a little bit concerned about, maybe. Alright, what'd you guys get for 1?
Yes, side angle side.
So, they share a side, so remember that counts. So it's side, angle. If we know this is 90, we know that's 90. Side, angle, side. Side, angle, side. I think there was a lot of repeats on this page, weren't there? So something that's not on this page is angle, side, angle. Hopefully you didn't get that for one of your answers, but that is one of them. Another one that's not on this page is side, side, side. So what,
You could get angle side angle on number 6.
well, you don't have a side on number 6, so you can't tell anything. 6 is one of those you,
Bisectors.
huh?
You got the bisecting.
Not that we know of. No, you can't just guess. You gotta know. So yeah, on some of these you can't tell. So the answer to number 6 was you don't know, or something like that. They could be 6 is basically angle, 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 right? But that's not one of them. Also number 9 and 6 are like identical almost. 9 was angle, angle, angle. That's not one of them. What's another one that was not?
What about that one?
Well, you have to have a hypotenuse or a leg.
Oh.
So you don't have any sides for number 9 or 6. Side, side, angle. If it makes a bad word, angle and side, side, that's not one of them. Number 2 looks like side, side, angle, so that wouldn't work. But in a right triangle, hypotenuse leg. So number 2 is hypotenuse leg. You just write like HL. Number 3, angle, angle, side. Because the side is not between the angles, so it's just angle, angle, side. Number 4, angle, angle, side again. Remember, vertical angles are always congruent. Number 5, that side in the middle is shared. So what do we got there? Angle, angle, side again. We did 3 in a row. 6, you don't know. 7. What do you guys think? It's a trick question. Can't tell, okay? If you only look at the first triangle, it looks like side, angle, side. So it's a trick question, because if you look at the second triangle, it looks like side, side, angle. They do have an angle in common, they do have 2 sides in common, but they're not in the right order. So 7 is a don't know, basically. 8. Side, angle, side. 9, don't know. 10. Side, angle, side. Alright. So on 1 through 8, you just have to remember that the big side is across from the big angle, or the small angle opens up to the small side, that kind of thing. So I got JKO. 14 is the small side, so J is the small angle. Number 2, I got LMK. 3, I got PRQ. 4, I got BUT. 5, angle C is across from 20, so angle C is the big angle. Angle B is the small angle. 6, I got Y is big, X is small. 7, I got U is big, W is small. 8, I got F is big, and E and G tie for small. Number 1, opposite sides of a parallelogram are congruent, so 8.5. Number 2, 22.1. Number 3, same side angles, like the same side interior angles, are supplementary, so they have to add up to 180. So you have to do 180 minus 145 is 35. Number 4, opposite angles are congruent, 75. Number 5, 4x minus 3 equals 13. Solve that algebraically, x is 4. Number 6, 65x equals 65, x is 1. Number 7, 3x plus 1 equals 2x plus 7. If you have x's on both sides of the equation, you gotta like subtract 2x to get rid of it on one side. X is 6. Number 8, this was the tricky one on this page. It's kind of like number 3, they have to add up to 180. So you can do something like 13x minus 4 plus 80 equals 180. That's how you set it up. And you should have simplify that is 13x equals 104. Divided by 13, x is 8. So just subtract 80 plus 4 plus 4. Okay, number 9, kind of the same thing, but instead of just finding x, they want you to find the actual angle. So to find x, you do 10x plus 15 equals 12x minus 1. You should have got x equals 8 from that. Then you plug 8 back in, and what was it, 95 for angle C if you plug 8 in for x. 10, same kind of thing, x minus 2 equals 2x minus 12. Should have got x equals 10, you plug that in for x, you get 10 minus 2, so KL is 8. Is that it, little thing?
Yeah.
Okay, let me, you guys can keep that, I'll give you guys some points for it. I haven't really made the test yet, but I do, this is what I'm going to make the test from, basically. Just not going to put, there's like 300 questions here, I'm not going to put that on. Just some of these. So, I just want to ask you guys a few questions that will be similar to the test to make sure we get these right. If you want to take notes on this, that's fine. This is not exactly what's on the test, it's just similar, you know. You know how we do it. Not a very good picture. Alright, call that F, that's an E. How many planes are in that picture? 6. How about name the plane? Oh, I didn't label these. E, F, G, H. There we go. How about what is the name of the plane on the bottom?
ABCF.
Okay, ABCF. You can just use 3 letters. You can use 4 too, it doesn't matter. You could say plane ABC or ABCF is fine. How about, you guys remember collinear, coplanar? Shares a line, shares a plane. Not too worried about that one. You need to know the names of all the polygons we talked about. You need to know concave and convex. You need to know how to find the angle, the sum of the angles. We already talked about these, but the sum of the angles in a polygon. You need to know how to find one angle in a regular polygon. You need to know how to find the areas. Okay, this was not in our packet because we just took a test on it. You need to know how to find the areas of all the shapes we went over. Parallelograms, triangles, circles, trapezoids, regular polygons, all that stuff. You need to be able to do, to identify adjacent angles, vertical angles, supplementary angles, complementary angles. Supplementary angles are like those angles that make a linear pair, right? Okay, that's a linear pair, but they're also supplementary angles. They also add up to 180. Okay, A and B, all the above. You need to know vertical angles are congruent, what they are. You need to, okay, here's a good thing for the notes. What are the ways we prove triangles are congruent? Side angle side, angle side angle. Yeah. So it might be easier to say the ones that are not, that don't work, because there's only like 2 of those. What does not work?
Angle, angle, angle.
Yeah. So these are no-nos. If you see that, the answer is
Not that.
we don't know. Okay. If it is angle, 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 it could be congruent. I mean, they should have congruent angles, but you just don't know. Like, these triangles, you know, have congruent angles maybe, but they're not congruent, obviously. But if the angles are congruent, then, you know, they could be congruent. But, then there'll be some problems with like the corresponding angles and stuff. Like if this is, what's that look like? We'll say 130 right there. Find angle X, find angle Y, that kind of stuff. If this is 130, what's this one right here going to be? 130. Corresponding angles. If that's 130, what's this going to be? 130. Vertical angles are the same. If that's 130, what's this going to be? 50. So stuff like that. I tried to not, I didn't really put any. The questions on this test will be easier than like a chapter test, but it's harder in the sense that you're supposed to remember everything, you know? So I tried to make it easier in general, but the hard part is you gotta know everything. Angles of a triangle should all add up to what? 180, so we'll put a couple of those on there. Also, you need to remember the isosceles triangles trick. We already talked about that, but
The 2 bottom angles are the same.
yeah, you gotta know these 2 angles are the same. You gotta know the angles add up to 180. You gotta know a little bit of algebra on some of these. Okay, on parallelograms, you gotta know opposite angles are congruent. You gotta know these 2 angles are supplementary. Same side angles are supplementary. Okay, the proof. So I'm trying to think of how I could do this.
It's not.
It's been so long since we've done it, right? Do you guys remember how we even started a proof? Well, yeah, but remember there was 2 columns? Remember what the statements and reasons? So on the test, they'll be nice and they'll write this part for you. They'll put like statement, reason, and then they'll put, they don't put 1, 2, and 3, they just put like blank space down below it. Anyway. I have one that I'm pretty sure I'm going to use this one on the test. I'm trying to think how I can help you without giving you that one. Maybe we'll do a slightly different one. How about that? I'll draw a picture up here. Yes. Yeah. You guys remember what is an angle bisector?
It's when
Yeah, it means it's, these 2 angles would be split. So if you know this was an angle bisector, you knew these 2 would be equal. Or if you know these 2 are equal angles, you know that's an angle bisector. There's also a segment bisector. Like if this was a segment bisector, these two segments should be equal. Or if these segments are equal, that's an angle. Anyway. Okay. J, how we doing? We're doing fine. I'm almost done. Gotta save the best for last, right? So, the given is, I guess I'll just put it down. They're not gonna write it down here for you, you have to write it down. Okay, I'll put it up here. Given is JM bisects angle J. So it's an angle bisector. And we're supposed to prove the triangles are congruent, basically. Alright, so what should I put first?
Line JM is congruent to line JM.
Nope.
Well, you should put the given first.
Okay, put the given bisects angle J, given. Everybody should get that at least, right? Okay, now what?
JM is congruent to JM. Line JM.
Okay, JM is congruent to JM.
Reflexive property.
Yeah, that was called the reflexive property. Okay, the one on the test won't be this one. I'll tell you that. It'll be more like the bow tie one. What was the bow tie one? Instead of reflexive, it's the vertical angles one. Yeah, those two angles in the middle are going to be the same. Reflexive property. And as you go, you kind of mark what you're saying, like those two are the same. Or that line's the same, both triangles. What else do I know?
JKM is angle JK.
JKM.
Yeah, there you go.
Oh,
The J angles are congruent.
okay. KJM, is that what you're talking about?
Yeah, that one.
KJM and LJM,
Yeah.
or MJM. Angle symbol congruent to MJL.
Definition of bisector.
Definition of angle bisector. Yeah. We know that because that's what angle bisector means. That's what it does. On this one, we probably should. They only show that, so I don't know if I would be that picky, but we probably should point out that both of those angles
Or right angle.
adjacent. Yeah, I'll skip it. That's okay. We'll take it for granted. So, do I have enough to say the triangles are congruent? Yeah. What do I have here?
Angle,
Angle,
side
side, angle. So just say triangle. Say JLM, JKM. Is congruent. Angle, side, angle. Okay. Again, that's not the one on the test, but it's, you know, it's in the ballpark. About the same difficulty level. And I did tell you it was going to be a bow tie problem, so. Alright. Areas of circles, we kind of mentioned that. Circumference of circles, you guys remember circumference of circles? Okay, Pythagorean theorem.
No.
Yeah. And I'll probably do, well, I don't know, I'm debating. Maybe one surface area of a prism or something. I haven't decided on that yet, but let's do one just for practice, just for fun. How about a that's lovely. We can double up on this one.
6 squared, 6 squared,
Okay, yeah, lateral area, remember, was perimeter times height. I need the height on this, let's go with 20, nice and neat. How can I find this side for the perimeter though?
It's square.
The fact that we didn't do
6 squared plus 8 squared equals what squared?
One square.
So what's C?
10.
10. What's the lateral area gonna be? Perimeter times height, 10 plus 14,
is
24 times the height, 20,
480.
480. Units squared, and then what am I missing?
The total area, which is times 8.
Right, since there's a right angle there, we can use 6 and 8 for the base and height. 6 times 8 divided by 2 will give me the area of this, but then times 2, because there's 2 of them. So 6 times 8 divided by 2 times 2 is 48, whoops. Divide by 2 because it's a triangle, times 2 because there's 2 of them. Add that to the lateral area, we get 5, 20,